welcome to everybody who braved a little bit of weather to come out tonight. This is Front Range Front End. If you wanted something different, I'll give you a quick break to discreetly leave. Tonight we're talking about web components, how to build custom elements that we can then stick into any framework, any CMS, all those things. My name is James Steinbach. I lead the meetup with Jason here, and I'm on a client project right now where we've been using web components for about a year. We've hit some really cool releases, and we've also been seeing in like the world at large, in tech at large, big companies jumping on board with web components. So kind of give you the elevator pitch for why web components before we get into the slides and all that. The dream here is let's build a component once and use it like literally everywhere. Let's encapsulate all the JS we need for logic. Let's encapsulate the markup we need as a template. Let's encapsulate all the CSS too, and bundle it all up into one little thing and then send that wherever we need to. And you can write a component that runs on your client's WordPress marketing site and can be embedded into their React product app and can be even wedged into that old ASP.NET thing they've been hanging on to since 1997. You can write a component that goes all those places and does the same functionality in all of them and looks the same. Regardless of the external style sheets, it's not going to get broken by a selector collision. This is some really powerful things. A couple big notes came out a while ago this year. Apple released Apple TV on November 1st, and right after that, some folks noticed, hey, there's a native web component running the video player inside this website. Pretty cool stuff. And then a few months later, Apple released a thing called Replay. You may have seen this if you use Apple Music. They collected all your data from listening to things, as everybody who has data on you does, and they made a playlist of your top 100 tracks and your top whatever number of albums, and it's a really cool little micro site, and you can see all this data and get your own playlist. That's also basically one giant web component with a bunch of tiny stuff inside of it. But the folks who run, we're gonna look at STENCIL.js tonight. The folks who run STENCIL picked up right away that, hey, Apple is using our thing to make components, and they were really excited on Twitter and talking about it pretty happily. So let's get into how we build web components. Yes, no? There we go, thank you, slide deck. So first off, how do we build them? What do? You just open code and get a blank JS file and then start typing things? Sure, but there's some other ways to make it a little better. There are some cross-browser concerns you want to keep track of. Deploy things that actually render consistently through Edge and Chrome, which are about to be the same, and Safari and Firefox. So we're going to talk about a helper build tool. And the two build tools I want to recommend tonight are not the same as a framework. Rather, what they do is they compile a bunch of syntactic sugar that you can use as you author components into the correctly polyfilled, depending on your browser support matrix, ready to go bundles. So we're going to talk about STENCIL.js because that's what I've got experience using. It's released by the INIT team. You may know them from past stuff with Cordova and Angular connections and the whole PWA thing. But also if you're curious and want to try out Lit Element, feel free. That one's run by the Google Polymer folks. Polymer was an attempt at web components that didn't super take off a couple of years ago, and they've just been kind of adapting, and now they're called Lit Element, and they do a pretty similar thing to what STENCIL does. They give you a bunch of cool syntax to make it easy and more manageable to write components, and then their build tool bundles it into just what the browser needs to be a native component. It's kind of like Sass and CSS. Sass doesn't go to your browser. Sass runs in your compile step, and then the browser just gets a style sheet that has everything expanded and ready to go. This is kind of like that for JavaScript, for building components. So if you want to get started with STENCIL, you can npm install it. This is all their docs are on their site, stenciljs.com, or maybe .org, don't quote me. If you just want to start it up in a folder, you run npm init stencil in your CLI, and it'll ask you a handful of cool questions. Do you just want to make one component? Do you want to try and make like an entire app out of STENCIL, which in my opinion is a little bit overkill. Portable components are a little better use case than one more new way to make frameworks. But yeah, and it'll ask you a bunch of questions. You'll give it a directory name, it'll create the directory, install everything, run the git init, and set up your package JSON, the whole thing. It's like create React app or view CLI or Ember generate, those kind of tools. So if you're familiar with the JS framework, this is going to feel pretty familiar already. And then we get into the code itself, and STENCIL uses a pattern called decorators to manage the syntax of what's going on inside of your component. And let's start by looking at the various decorators STENCIL offers and what they do. The first thing you probably want to do with a component is pass it a property, right? It's no good to have a component that has no properties, because what's it going to do? It's just going to display things. You might as well just write markup. But if you need to pass a prop into your component, you register it in the JavaScript in STENCIL with the @prop decorator. And here's a code sample. You're importing all the things we need from STENCIL core. Component is the first decorator that every component file needs. I almost should have made a slide on its own for that. It gives it a tag, and that tag is the HTML tag you're creating. One quick note, you have to have a hyphen. That's not a STENCIL limitation, that's a browser spec issue. All custom components you make have to have hyphenated names. So your component needs to have a hyphenated name, and that component decorator can have a few other things. You can point it at the style sheet that will get bundled into that component as well. And then it also has a flag for turning shadow DOM on or off, and we'll talk about shadow DOM later. That's a cool, fun word. It makes you think of darkness and espionage and cool secret things, and it's not. It's more technical. So then we're going to create a class called SayHello that matches our tag SayHello. That doesn't have to match the camel case versus hyphenation. It's just a good practice to name things the same. And we're going to register a prop called name, and that prop has to be a string. STENCIL comes with some TypeScript running, so it keeps things locked in and makes you not change the type of a variable as you go. So we're telling it that string is the type for our prop, which is called name. And then our render function. Anybody who's done React probably familiar with the render function. This is kind of like JSX. The H we're importing from STENCIL core lets us do the JSX-like syntax. And I want to clarify something. This is not exactly JSX. It's kind of like it though. You use class instead of class name. But other things like tab index are still get camel case to be JSX and not HTML native all lowercase. So I hate to put it this way, but it kind of could be a little trial and error when you're naming an attribute to name it the right way. I wish that were a little cleaner, like it was all just JSX, the normal way, or just all HTML the normal way, but this is what we have. There are a couple places where it's not perfectly JSX. But then it looks pretty familiar. We're returning a component or an element, a paragraph tag with hello world, and then this .name gets our prop name. So if you instantiate this property or this component, you put say hello, name is nothing, or don't even put a name attribute on it in your markup, you're going to get undefined. You can set a default value. Instead of doing name : string, you could do name equals empty string. And that would also tell TypeScript, hey, this has to be and stay a string, but we would at least have a default value there. It's up to you if you need to do default values or let it be undefined. Kind of depends on partly what kind of prop you have. If it's something coming in like a Boolean, undefined usually works okay for the tests you need to run, but yeah. And then to use it, we do this. Sorry.
No, so the component has to have a hyphen in the name. It can't be a one-word.
Yes, the tag has to be a hyphenated string. You cannot just do hey and call that your tag name. It has to be hyphenated, and that's just a spec that browser vendors have decided on for custom components. If you're making components that match a namespace or a prefix that matches your project or your company or your app name, then that's easy because your hyphenated thing is the prefix, and then anything else can be one word if that's easier for you. So the first block is what we would put in our markup after we've added this component to our site. And the second block is what it's going to create. When you go to DevTools and inspect it, it'll still show you the outer component named SayHello. It'll show you the prop that you put on it, or an attribute as it looks like because it's HTML. And then it will put your content inside of there. And if you turned on Shadow DOM, you'll have to do more expanding to open up the shadow root. But that's all inspectable in DevTools and Safari and Chrome and Firefox, and Edge is a different story, and I'll talk a little bit more about that at the end, time permitting. Edge is exciting, and I can't wait for it to turn into Chromium for this use case. So that's props. You need to pass in a piece of data from outside of your component. What if you need to track a piece of data inside the component, and maybe it changes over the life cycle of the component? State lets us do that. And if you're used to things like React, you've got props in state, and you're used to this language. So looks pretty similar to what we had before. We're importing a component. H lets us have a render function, and state from STENCIL core. We're going to name this component a click counter, export it, and then the logic inside will look like this. We'll define state and give it a default value of 0. A default value of undefined would be really bad. Even if we said make sure it's an integer, make it 0 to start with. And then we're going to create a private method. This is just a function we can call with this dot function name. And that will take our count and it'll bump it up 1 every time we call that function. And the next thing we need is a render function. This is a little longer. This is subject to the same rule as React pre-fragment and Vue and other components, templating languages inside of frameworks, where you have to have one root element for every component you build in the framework. You also need to have one root element in everything you do inside of a STENCIL component. However, they give you a cool thing, which is host. And if you use the host component, which is a part of STENCIL, that just means whatever the actual tag is, and that does let you put in multiple sibling children into that component without having an extra div there. So we don't have to divide it, but I did just for the sake of the demo, sorry. Your return function, if you want it to be, can also return an array of elements, and that'll also let you put multiple children in there. Host acts a lot like React.fragment, only you can actually attach things to it like class names and all that. I'm not familiar enough with React fragment, maybe it lets you do that too. If so, cool, let me know later. So we've got a button here, and we're going to call the onClick function on the button, which is going to be a function that runs this .increment count, which increment count was up here. It takes our count state, and it adds 1. And I'm going through these all slides pretty quick. I do have demos for all these components, and we'll actually look at those, and we can open up code. And if you want to see more of what's going on behind the scenes, absolutely willing to walk through that as part of the talk. Watch is pretty fun. If you need to keep track of a state or a prop and run a function every time it changes, watch lets you do that. Again, we're importing it from STENCIL core. Here we're watching the name prop, and if somebody actually changes the name prop, on the markup where they've used the component, we can run a function. Maybe throw a JS alert that says, hey, welcome, your new name is X. Whatever function you attach to the end of this watch decorator has 2 parameters, new value and old value. And hey, welcome. And you can use those to run tests and logic. Maybe you can do a little validation here. If you're watching something coming in through an input, you can watch it, you can compare the new value to the old value, only run certain things if it's changed, as opposed to somebody clicking around and choosing the same select option a bunch of times. Or if there's invalid syntax or input, you can also use that to throw out errors or send error state to other parts of your component. So watch lets you watch something going on. And it could be state or a prop that you watch. So the rest of the component would look like Hello World in this thing, and there's nothing fancy in the rest of it. Now this is always a fun topic. What if your component needs to listen to or send events to other components? This is kind of a weird, fun, magical part because it doesn't have to happen based on parent-child inheritance. You can send things sideways, it feels like, but really it's up to the top and back down again. With the event decorator from STENCIL, your component can emit an event with a certain name, and any other STENCIL component you've written can listen for that event to happen. And you can scope the context in which it listens. You can just always listen to document, and that's cool. Or you can set that event listening target to something smaller, like another component or another element inside your app somewhere. But what does that look like? Let's take a cool example of a modal trigger and a modal window. Everybody loves modals, right? We need like 90 of them in every app. Let's start by building the trigger first. The trigger has to send an event that tells its window, hey, you need to open up, right? So we're going to import event and event emitter, which is just a TypeScript interface we need to use when we define the event from STENCIL. And then we use it inside of our component like this. Event is going to be called open modal, and it's by default just going to match the event emitter pattern. And then again, another private function like we had in our click counter that runs this .open modal emit. Emit can also take a payload. If you need to send a block of data, you can do that here too, which is a great thing to do. You could, the HTML pattern of label has a 4 that has to match your input's ID. You can do a similar pattern to that, where your modal has an ID and your modal trigger has a prop for its target ID, what it's for, what it controls. You could even, since we're doing custom components here, we want to make sure that we do accessible things. use ARIA control by and ARIA controls and make sure those strings match up between the modal and the modal trigger. But in the emit function, when you send it, you can put in a little object there and send the name of a modal window that should be listening and should only open if its name is the same name as you emitted from this event. So you can pass data. And then return, the render function's looking pretty similar. Once again, an on-click on a button. And I'm gonna come back to slot. Slot's kind of cool. If you've done view, it's just like that. If you've done Ember, it's like yield or outlet. If you've done React, it's like children. All these things, I forget what React call, or Angular I can just call it slot too. But yeah, it just says whatever you wrap this element around is gonna go there in that slot section. So anyway, this button is gonna fire the trigger click event, which is going to emit an event named open modal, and if you wanted to, you could pass an ID along with it or some piece of data. And then our modal window needs to listen for that. So this part is probably getting a little familiar, the same boilerplate component. Our tag name is modal window, and the class is going to start with a state, which is open. It needs to know what it's doing, right? Is open should be true or false. And then we're gonna listen for the open modal event. And then if we listen to open modal window around an event object, that would be the payload that came in from the emitter. And if we hear that, then we're gonna change this .open is open to true, and use whatever CSS we need to change the layout and make it visible. Here I'm doing classes with an object syntax. This is kind of a, depending on how you're organizing your CSS, you could have a string where you interpolated things, but I like the object is a little cleaner. It's always going to put the modal class in that object, and then the string modal -- open will only be there if this open is true. And then we're just gonna put class equals modal classes, and the curly braces probably remind you a little of React. Yeah, and that object of classes gets turned into a string when it gets sent to the browser. So now we've got a class that toggles on and off whenever that is open state is changed, and that class can then be tied to your CSS for a transition, an animation, the display you need to make the modal actually show up for a customer or a user of your site. So that was 2 components for the price of 1 mini demo. We had a modal trigger that opens a modal window. And the cool thing is the modal window doesn't have to be anywhere close to the modal trigger in your markup. A lot of apps have like the idea of a portal or a wormhole. You may have seen that in other frameworks where you define an element that's just the way at the end of body and you send other things to it. And that's how you can get a modal window markup near the trigger, but also have it actually rendered in your app in a separate place. And that's cool and fine and good, but this kind of makes that not necessary anymore, because you can just drop modal window at the end of your page and it doesn't matter, it's cool there. So things can go in the most sensible place, but the events fire back and forth the right way. The magic of events just kind of firing up and then coming back down to something unrelated in terms of the DOM reminds me a little bit of the view event bus pattern, if you use that to send data back and forth between trigger and recipient components. Which I'm not going to talk about that would be a different topic if we had a view meetup. But yeah, if you're used to view, hopefully that's a comparable analogy. So then we would use this markup like that. The words login are inside of this component, so where we have that slot element, that's where login is going to end up rendered. And then modal window also had a slot, and this form is going to go in there. And of course you'd have real things in the form because nobody needs an empty form. And you can bind all of your accessible attributes to your state, just like you would want to. Is open can control ARIA hidden, true or false. That is open flag can control like a ARIA live attribute if you need to announce a change in your content. All the things that you want to do to make an app or a site accessible to users, you can do. So yeah, that brings us to the end of all those properties. Want to dig into some demos and see how they look in like real code?
Yeah.
Cool, we can do that. Where did you go? I don't want that one. Oh, that probably just killed my, I'm smart. I think it just killed my live slides. So anyway, cool, yes, we're way taller again. Here we have the whole app I've got running. This is all the stuff that STENCIL built for me, but I of course added new components to things. So like we've seen here, we've got all the same components. Let's start with name tag. That's the one we looked at first, the hello, my name is. I didn't know when I made this that they were going to paint a name tag on the wall right next to me. All right. better. So we've got a name tag here, and of course it's styled, CSS does that. And the name is, as you would expect, a prop. But that looks like, that I did not want to do. This in our component. We've got a style URL we're adding, which is SCSS in this case. I kind of like Sass. You can set up STENCIL to run basically anything that's rollup compatible. It uses rollup for processing assets. So yeah, you can run PostCSS in there, you can run Sass if you want to, and make your style sheets manipulated as well as you need to. I love it because you can post CSS in there, and auto prefixer can run before it ever gets to a browser. All the same compile stuff you would want in any front-end project for your styles. In this case, we are locking down the shadow DOM. That's what shadow true means in the end of the decorator. And what locking down the shadow DOM means is no styles can get in and no styles can get out. We're going to talk more about how styles get limited and the ways we have to actually get through that barrier if we need to in just a few minutes. We've got a whole zone about how to style these things. But for now, we're bringing in a style sheet that has cool things in it. Yeah, colors and whatnot. But all we do is have a prop called name, and we use it right here. And to see what that looks like, even the tab panel is a component, FYI, on this page. So yeah, here's what name tag looks like. And we'll come back to this when we get into styling things, but if I change it to whatever we want to, boom. And just hot reloads. STENCIL has the cool stuff built in, so your local dev server works really cool. And things just happen. So that is how props work. Any follow-up questions on props before we move to state and beyond? Cool. Yeah, props are a fun place to start. State is fun. We want to do a click counter, right? And if we're tired of clicking, we can drop back to 0 and go up again for a while. Maybe we just want random numbers. All of this is pretty trivial. And again, if you're familiar with any of your JS app languages, or your frameworks, you've seen this kind of thing before. And click counter looks like this. We've got a state, which is our count value starts at 0. And then we've got several functions that do things. Increment count bumps it up by 1. Clear count always drops it back to 0. And random count gives me a random number up to 100. And then the markup looks like so. We've got a paragraph that shows us what's actually rendered. We've got a button that does increment count, a button that does clear count, and a button that does random count. And those affect state. And you saw it live a second ago. Anytime you click something, you get numbers. Any questions on state or that demo? Wow. Either the demo's too easy or y'all are like awesome. I'm gonna vote for option 2. We can use a watcher on state, and we're gonna do that in a second. You might have noticed there's a much larger gap underneath, because by watching state, we can do cool things like a FizzBuzz component, everybody's favorite. I always like when the random one lights up both. All right, but I respect your time too much to keep clicking. So that is our FizzBuzz component. And this one's a little longer because we start with a count of 0, same as last time. We're going to use a class to trigger that secondary content. And I'm using just before and after pseudo elements to put the fizz and the buzz into. You can also conditionally render things. And it looks just like your JSX logical rendering inside of a React component, where you can say, if such and such is true, then do this. You know, a true condition and a component name will work. The projects I've been on, I've enjoyed the direction of the other developer I've been on, who's insisted on having render functions that you call, and the function contains a logic, so your markup just has render functions and curly braces. Either way is cool, whatever your team likes to keep it clean. So the class is always going to be FizzBuzz. Same things here, incrementing, zeroing out, and randoming. But now here's our watcher. A watch is always going to watch count, and it's going to run a function here. FizzBuzz is always going to start off equaling FizzBuzz. If our count is greater than 0, cool, then we do this. If it's evenly divisible by 3, we fizz, and if it's evenly divisible by 5, we buzz, and then we join those all, and that's one long space-separated class string now. And that goes into our template right here as a string. I could have done that object for classes pattern that I showed y'all earlier, and that would be cool too. In fact, I was looking at that this afternoon and I almost refactored and then I got distracted. So yeah, multiple ways to attach multiple classes. You can do a string where everything's concatenated or even interpolated with, you know, your backtick and your dollar curlies. Those work great because it's just JavaScript here. And then our buttons do the same things. There's nothing different about the render function, except that we added the dynamic class. If I wanted to do watch the change, again, as mentioned earlier, we've got new value, old value. I could test that in here too, and in fact, that would probably be a better way to do it. New value, and then test new value instead of this dot count. Either way is fine, but if you don't have to use it, whatever, your call. They both work. This is a lighter, simpler demo though. So that's FizzBuzz in a STENCIL component. Any questions on that one before we check out our last demo here? Well, the JavaScript side of our last demo.
I'm not entirely sure about the difference between the watch and state.
Sure. So state holds the data. That's like a variable inside of our component. And watch says run this function every time the variable changes.
Okay.
It's like component did update or use effect.
Yes. Yep. So it's kind of like, we don't have to have a lifecycle hook. There are lifecycle hooks in STENCIL too, like you have in React and other places. You could do all this logic inside of a will component update, or component will update, or component did update. But watch is a simpler syntax that gives you access to old and new values right there built into the function. And so yeah, that's why we go with watch. Cool. And that brings us to our last two components inside of this demo, which are modal trigger, which looks just like what we saw earlier. And our modal window, which I call modal pop-up, which looks a lot like we had here earlier. Oops, who put console logs into things? That guy's fired. So yeah, we've got all the accessible markup if you're cool with those kind of things. We've got aria labeled by to get the modal title and put it up there, associate it there. We've got aria hidden for the is open state. We've even got, go away hover things. We've even got role as dialogue. We've got buttons inside of our modal that handle closing it. You don't have to emit a close event from something else if the button that closes the modal is always inside the modal. So yeah, we've got a close modal function that lives inside here as well. Here's our listener. If it catches an open modal event happening anywhere else in the app, all the way up to the document, that's what the target is setting here, it will fire the open window function inside here. And again, like I said earlier, we would want to pass an ID from the trigger and test that ID here in the open modal window. So we don't open all of the modal windows we have in our app when anybody clicks any one button. That wouldn't be swell. You get frustrated users. But that looks like this. Here's our modal trigger. And if we click it, we get a modal window. And just through CSS on there for animation and layout and that kind of thing. And both the confirm button and the X and the background scrim close the modal window. And that was this many lines of JavaScript, 47. So yeah, pretty cool things. The modal trigger, that was slightly different. Yeah, that's another 20 lines. But yeah. And in the markup, those look entirely different. Our tab panels over here contains modal trigger. And it's actually all the way on index HTML where I dropped modal pop-up in. So these aren't related by nesting or by parent-child, like passing, like Ember has a whole like data down, actions up kind of deal. You don't have to worry about up and down because with the event emitter, you can emit event from any component that needs to and listen to it from any other component that needs to listen to that data. So those are the JavaScripty template sides of our demos. If we continue, any questions before we do? Yeah.
So that target document, you said that the event bubbles up, then goes back down. How exactly does that targeting work? Does it intercept it?
So yeah, documents all the way up to the top of the page,
Yeah.
and I haven't done a lot of my own work with what else you can put into target.
Okay.
It would probably have to be a JavaScript selector function, like document query selector, that kind of thing. But once you get into that, you end up with a weird spot where there's a query selector variant that has to run inside of element.shadowRoot if you've got your shadow DOM closed, and it gets kind of confusing and kind of a lot more verbose to limit it to a certain other stencil component. But document is, it's a thing for your team to decide, or you decide in your app, do I want this to clutter the global zone and bubble all the way up to document and come back down, or do I want to forcibly intercept it somewhere smaller? Yeah, I believe the target attributes, or the target prop supports that inside that object.
I have a question just showing about the render cycle.
Yeah.
Is it using a VDOM, like say React is, or is it using something else? But every time it re-renders, say when the state changes, what's happening?
Yeah, so that's what the browser optimizes, because this is a native component. So as far as I know, it's not technically virtual DOM the same way a framework would. It's the browser having registered a custom element and a bunch of custom getters and setters inside of it is what it roughly compiles down to. So I don't know that it's actually virtual DOM, but it is all happening with a fixed cycle of events, and some of those are native, and some we're going to look at in just a second are some stencil syntax around some of the native ones.
Okay.
Like watch with syntactic sugar around native will update, did update kind of things. And Stencil has a great page on their website that documents all of what I'm about to show you in 4 or 5 slides, and even has a cool chart with looping things and dots and dashes and arrows. But yeah.
Do you have to include a stencil in your page?
No, when it compiles, when you run the build command, which is you're jumping to the end of the slide deck, which is cool, it runs and builds a bundle for you. And the bundle comes with an entry file and a couple other files that it pulls in.
So you use this on this page, what is the left?
Yeah. If we look at the demo and view source, we get a lot of console. The body just has the elements we defined: tab, panel, modal, pop-up. Those contain what they contain. And there's a script tag, which is a service worker. And there's an iframe that handles some live reload stuff. I'm trying to figure out where they put the actual JavaScript. Yep, up here. And these are the actual build files for the whole bundle. What Stencil does is if you have a bunch of components and they're all nested and that kind of thing, it'll give you one bundle.
And that kind of is rendering this DOM.
Yeah. So yeah, the whole thing is not worrying about ways to make the browser more efficient, but giving the browser the ability and the knowledge to make these components run really at the browser, at the metal, as it were.
Is there a way you can actually see like the component structure from the stack?
So yeah, if I open up tab panel, we're going to see that I've got my shadow root here, and it is open, it says. It's got a style block inside. This is how components work. They get an inline style block. And then inside of there, there's a markup that I put inside of there, a list full of tabs and a list full of panels. And if I open up a panel, it shows me what's inside of there, a title and some contents, and here's my click counter component. And it's got a shadow root as well, where I've put a style block, because again, with the style URL in our app component decorator, you can call a style sheet from that folder. All the CSS that file needs, the component needs, and then all the markup from the render function. So yeah, the template goes here, the style sheet gets compiled to here, and the JavaScript all ends up in here. We're authoring it all in 2 files, but that's the way Stencil splits things up. And really, it's JavaScript that contains a style block and a template block and the logic, but yeah. The styles and the template are all visible in your DevTools. And you can see, like, Firefox recognizes it's got an event attached to it, and it gives us the line for where that event comes from. And we can jump in if we wanted to and inspect what's going on. And yeah, because it's kind of minified, it all looks stupid and one-liney, but yep, that's our code. So if you need to hook into lifecycle hooks and run certain functions when certain things happen, you can do that here. And let's take a look at them. Connected callback and disconnected callback, and all these slides are going to have two things that are, two sides of the same coin kind of situation. Connected runs when this element connects itself to the DOM. It doesn't run a whole bunch of times, but it's the first thing that runs when your component gets registered and added to the DOM. No matter how many times you use the component on the page, when that instance of the component is attached, its connected callback will run. And disconnected callback happens when you remove a component from the DOM. If you delete it, there's a remove function that we won't get into that's a little more deep end. The disconnected callback will run. You can use that to destroy listeners, that kind of cool stuff. If you fire up a bunch of like resize observer or event listeners inside of your component, you want to trash all those and free up that browser brain if you destroy or remove the component. Connected callback is a great place to wire up things to what's going on inside your template. Inside connected callback, you can access the rendered DOM if it's ready, but there's a better place to do that. If you have, there's a bind pattern where you can create something, but to make it a click handler, if you don't want to always use that parentheses fat arrow, then the function name, you can bind functions to this, and that's a little better. It's a lot more code above your template that makes your template shorter. But we can look at that in a second. Component will load and did load kind of sound like what they do. Will load runs once after the component connects to the DOM, so it's connected callback, then will load, then we get into render related things. And did load happens after the component is fully loaded, after its first render. It doesn't keep running after subsequent renders, there's a different way to hook there. But it runs once after the component finishes its first render function fire. Will render happens before every render, and did render happens after every render. So did render might be a great place after your DOM is all generated to attach some event listeners to things inside of your template, to fire a resize observer if you want to, or an intersection observer. Maybe you're doing this to be a lazy loaded image component is what you're working on. Fire an intersection observer inside there. Maybe your component's trying to always listen to its own size and be responsively styled to its own width, not the viewport width. You can use a resize observer, hook it up in component did render probably. And then will update and did update fire around every prop and state change. I mentioned earlier you can use @watch to track those changes and run functions, or you can use will and did update also. Watch is convenient because it gives you old and new value baked in, so if you need to logic those things, that's a great place to do it. And component did update, both of these, it's worth noting, run before and after every render, but not the very first render. So you won't get will update firing on your initial render. But these will run after every proper state change happens. Any questions about the life cycle?
Those are STENCIL templates or?
Yeah, those are part of STENCIL, and a couple of them are part of the native spec as well. But STENCIL also compiles it down to everything matches the native spec at the end of the day. So this is a fun thing we all came to talk about, right? Shadow DOMs. It's my favorite part. I'm kind of a CSS geek. That's my primary responsibility, work, templates, and styles. So Shadow DOM is kind of my favorite part of this game. Completely scoped styles. Outer styles can't leak in. You may have recalled that I gave my tab panel such detailed class names as panels and panel, and then panel title and contents give us a little bit of scoping for them stuff. And my tabs are simply called tabs and tab, 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 tab. That's a stupid common name, and you would never want to do that in a plain old CSS app that's going to be embedded in something else, because chances that something else has a panel class are mildly high. It's not negligible. It's significant chances. But here we can do that totally safely if our shadow DOM is closed, because what the shadow DOM says is, I don't care what CSS is on the rest of the page, I'm not going to let it touch the components inside of me. And also, I don't care how loosely and broadly, you could style everything with just H1 and LI and UL inside of a component if that's all your markup ever was, and it was safe enough to do so. And those selectors, which are hugely broad, will get out. They won't mess up the rest of your page, which makes this awesome for embedding. I suspect it's one of the reasons the Apple team chose a component to build their video player for the Apple TV experience, because they can drop it into any part of their web ecosystem. Doesn't matter which of their sites they want to drop a preview or an episode or whatever into, that site's CSS is not going to break the player, and the player is not going to break the site's CSS, which is kind of cool.
Really useful.
Yes, especially in the age of like CSS and JS and hashed class names and selectors and all that kind of stuff. We don't have to fight and use machines to make up 9-character gibberish strings to try and prevent that. We can do that with a browser technology, Shadow DOM. And class names can be human readable, and the dev experience is clean, and it doesn't confuse you, and you don't have to worry about, is this going to compile to HGZ934-5? It's just going to be tab, and tab is going to be scoped to one context. It's like an iframe on steroids, maybe, is a way to think about it. It's locked in there. And in STENCIL, you turn that on or off with a shadow property inside of your component decorator. If you put shadow false, that opens up the shadow DOM. Your styles will now be exposed to the rest of the world, the rest of your site, as will your elements and their selector names. So if you really wanted to have a component that was nothing but markup, you don't care what it looks like, you're going to trust the end implementer to style it the right way, open up your shadow DOM. Cool, cool, cool. There are new selectors we get with Shadow DOM. This is part of the new CSS spec that's in draft mode and working its way. This whole thing is pretty stable in terms of browser support. There are even polyfills for IE11 and Edge that you can run in STENCIL. They're weird. I don't like them. They make a lot of extra work, but it'll still run. That's the end of the day, important part. The polyfills let it actually run correctly in Edge and IE11. But we get new selectors. You made a component, it's got its own tag. It's called modal-popup. How do you style that tag from inside of its own Shadow DOM CSS? Host. And we'll dig into these more. I forgot summary slide first. Host parentheses around another selector. Host context with another selector in it. You remember the slot element we saw earlier? You can style things that are pushed into the slot element with a slotted selector. And part gets an asterisk because it's not even described in the draft yet. The other ones all are. But part is kind of implemented in a couple of browsers. You can guess which two. So here's an example of how you might use the host selector. Turning all your hosts to display block or whatever display you need to is actually a good idea if you're running polyfills and sending this back to IE11. Otherwise, IE11 says, what, new tag name? Must be in line, and just kind of compresses it all down. Whereas every other browser is like, what, new tag name? Probably a block. So yeah, always make sure you give an explicit display to your host selector if you're backfilling far enough for IE. But what if your host has a dynamic class and you want to change the color of its contents when the host has a modifier class, say is blue? You wrap the parentheses around that class. You can also do host parentheses around an attribute selector. This kind of matches what we did earlier with our tab panels. When the panels aren't visible, their ARIA hidden attribute is turned to true, and the CSS hooks right into that, and opacity drops to 0. So any class, any attribute, any selector thing you can do, just regular CSS selectors, can go inside of that parentheses on the end of host. Host context says, okay, let's get out of the component and see what kind of DOM tree it's in higher up. This, in my opinion, isn't really the spirit of web components, but it's possible. If you want your component to be 50% wide when it's in the article, the main section of your site, but 100% wide when it's in the sidebar, the aside of your site, you can scope your CSS like that. There are other reasons to use aside tags for more than just a sidebar, so be careful. Yeah, components that depend on their parent DOM markup to style themselves a little differently is not my favorite, but if you're tightly controlling the whole experience, that might work well for you. Here's a good example. Got a button component I did a while ago for work, and the button just has a button tag wrapped around a slot, and inside a slot you can put whatever you want to. And sometimes it's just a word, other times it's an icon, which is an SVG, and then a word. So in this case, if there's an SVG in the slot, we give it padding or margin right to push it away from the text, and we set the width max 22 pixels, just to keep it all the same right icon size. And we're going to use the compound selector still inside of the parentheses. If you're used to nesting with post CSS or Sass and you do slotted SVG curlies, then star curlies, and try to set your fill inside the nesting, not consistent behavior, doesn't do exactly what you want. Put the star inside of the parentheses with the SVG. But that'll find all the paths and all the, shapes, rectangles, circles, whatever, and make sure their fill matches the button foreground color. And here we're sliding a little bit into CSS custom properties because 90% certain that if your use case and your browser support requirements lets you do a stencil component, you can also do custom props. Backfilling far enough for IE11 is the exception to that rule. So we might use these in this way. Oh yeah, this is the part, sorry, one more slide of showing you things. Asterisk, only Firefox and Chrome support this. They support it pretty similarly, but Spec doesn't even have a write-up of this in the CSS draft for Shadow DOM selectors. So super wary about part. Here's what part does. Part says Shadow DOM, let's create an exception. And it lets a custom component, a web component, take one of its children in its template and expose that to the outer world on any CSS you want to put in there. Not any CSS, it doesn't hit global selectors because you have to style it with a part. So in our first part up here, the button is named the part trigger, modal trigger kind of thing. And now we can grab our custom element's name. It would be modal trigger or modal open or modal whatever we named it, and do : part trigger, and that string just has to match the value of part, and we can change its color. We can change its whatever. We can scope CSS to that, but the CSS block on the bottom here is not inside the component. The call is not coming from inside the house. That CSS is from outside in your external, your global style sheets. But part is a way to sneak the ability to style an inner element inside of a template. Usefulness, maybe. But there's another way to create stylable, themable components that still have everything Shadow DOM locked down, that still have all the right base, the right default styles, but still let people intelligently and correctly get style modifications inside. We're going to build an API with CSS. And I mentioned custom properties a moment ago. That's what we're going to look at in a second. CSS custom properties are the only things by default allowed to pierce the shadow, allowed to get into that Shadow DOM. Let's check out an example. Oh yeah, it's our old friend, the button. This looks pretty familiar. And here's the style sheet that gets attached to that button component. Button is going to be foreground color for its color, or if nothing's defined, we'll go with white. Background is going to be the button background variable, but if it's not defined, you go with, I don't know, I can't read hex codes, but I think that was blue when I made it. And then if we hover, we're going to have two different variables. Button foreground active, again, if nothing's defined, we'll stick with white, and button background active, and if nothing's defined, we'll go the darker shade of whatever color I forgot I pasted above. So that's going to be styled the right way by default. We've got a brand color in there. We've got the ability, though, through these custom properties, to change that color, any of those four colors, as we need to. So this is what we would put into like our, oh, it was blue. This was blue because this is red. Good, I made myself a note so I remembered. Here we're going to change our button background color to this shade of red, and our active button background color to this slightly darker shade of red. We're going to keep the text white in both cases by not overriding that custom property. But if our button lives inside of a container, doesn't have to be part of the Shadow DOM, it could just be a div that's sitting inside of in our site somewhere that has that selector and those properties defined, we can reskin to a degree the buttons. This means that you as the component developer have the control over what you allow in. Every single CSS property is not up for grabs unless you write it all into your style sheet. So some cool things to do are, active colors, maybe a focus border color, maybe a variable that does left to right padding. Maybe it's going to be full width or content width. Some of these kind of things as your design system makes variations on buttons. Those are the custom properties you create and the ones that you allow people to target from the outside. Quick caveat, all custom properties are just custom properties, so you can't expose just a handful of custom properties, but use a handful of different custom properties that are secret and used like variables, but only in your Shadow DOM. If you really want to do that, I would say, get Sass installed and let it do variables precompile for that side of it, and then use custom props for the API. Or just use custom props and do something cool like name them really weird things that nobody should be able to figure out accidentally, hopefully. But yeah, that's how you create a custom property API to skin or theme or restyle within the modifications allowed your component. Any questions about CSS before we move on to the how do we deploy? And how do we deploy, to give you all hope, is the shortest one by a long shot. Any CSS questions? Oh, I said we had demos, we certainly do. So here the style URL is getting tab panel SCSS, which just lives right next to tab panel TSX. And what I've got here is my host, and I've set its margins to auto. It's centered in the page that way. I've given it a width of 100% plus a 2rem border on each side. Given it a max with a 30 ems, display block, because that's a good thing to do. The tabs is just a flexbox container. Each tab has, margin, color, this kind of thing. No variables here. We're using ARIA selected and ARIA hidden to actually style the visibility and the affordance of click active or inactive on the tab itself, which is a great pattern that I love to recommend every chance I get. You could manage classes and ARIA attributes, or you could just write the ARIA attribute part first and hook your styles into those. And now you've served screen reader users and sighted users, and they're both happy, and you haven't duplicated an ARIA attribute with a class name. I like to recommend that. It's my favorite way to go. But for an example of variables, I promised we had those. I'm gonna go back to our name tag. Here, our name tag background has a variable exposing it as a themable property. It's gonna be red by default. And our marker color, yeah, because we have marker felt font too, is gonna be a darkish gray, but that's themable if you get a hold of this variable name. So go back to our name tag, cool. And I'm going to jump back over to tab panel where the name tag is used. And, all right. Data style does absolutely nothing. That was just there so I don't have to type it all at once. Let me clean this up for visibility. Everybody like visibility? Is that cool? So yeah, we got ourselves a little object. And now it actually is shaped like an object. Very cool. Because we're using a render function in this case, it's inside of a component. I'm using an object to run the styles. But if you were doing this in actual real life HTML and just using the name tag element in the middle of a block of markup like in a WYSIWYG or wherever, you would just use a string for your inline styles. But the rendering engine will yell at me if I try that here. So I'm going to change name tag background to blue and the marker color to this weird color which I randomly typed a while ago, and I don't know exactly what it is. And here's our hot model reloading. The server doesn't work great, but I refresh it and it behaves. Slight limitations to the reload. But yeah, now I've got a nice blue background, and I don't know, I'm colorblind, but I think this is green-ish. Yeah.
Piece of mustard gold.
Mustard gold, all right. I've never randomly generated mustard before. So yeah, it's like clouded a chance of meatballs. But yeah, we've got, these things are stylable now from the outside. So that's styling things and the custom property deal. There was one more thing I had. Oh, if you were curious about lifecycle hooks, all the logic, the JS that runs those tabs and the connection between the active tab and the ARIA attribute on the visible tab, I'm running that all in component didLoad because the markup all needs to be there before we can attach events. And I have to get this element, shadow root, then query selector all as an HTML element because TypeScript, then the actual selector. So this is a lot longer than like jQuery $. And I also have to instantiate the element as a targetable thing with yet another decorator. So the lifecycle hooks can get verbose pretty quick. The more logic you have going on though, brace yourself for that. But other than the fact that the selector line is like 30 characters, or I don't know, 70 probably in this case. It's probably no more logically complicated than most of your selectors in any other app. In fact, if I wanted to, I could do something like const root is, this. And make things shorter, you can do whatever you need to. Or I could write a function that does the query selector all and forces typing as HTML element and make that a method in the component. y'all are smart devs, you can figure out refactoring. So there are ways to make the really long selectors more manageable. So yeah, so okay, so we've gone through all this. We've learned how to set up STENCIL. We learned how to write the component. We even got a prop and a state and a listener going. Now how do we get this stupid thing onto our website? It even looks good. We even put CSS on it. This is great. How do we get it into our website? Well, the short answer is do npm run build and get the contents of your dist folder onto your server. Ta-da! And then you link to the entry file in that dist, and it links to all of its sibling files. It does some bundle splitting, STENCIL does. Since we had like 6 components in the little demo app, it actually has 1 entry and then 6 things that it'll import. And so it kind of speeds up some of the processes for how quickly things load, more requests, but faster simultaneous things. And once we ever get HTTP2 turned on everywhere and a lot of little files becomes more performant than one big one, you know, we're already skating to where the puck is going to be here. But what if you're not doing that? What if you just need to externally host them? What if you need them in your build process? At this point, I refer you back to the STENCIL documentation. They have docs for Angular and React and Vue and Ember, and show you how to run STENCIL alongside of those apps and how to get its component JS files into your app's component files and into your bundle as a build dependency. So yeah, I don't know which of these frameworks you all like best. I don't want to teach all 4 of them, but the docs are there and they have code samples, and it's a pretty cool process. Which brings us to, ta-da, the end. I'm James, as I mentioned earlier. I work at Dockyard. I like to say that we're hiring. Right now we're actually not though, but if you want to bookmark dockyard.com/careers, we love hiring awesome CSS and HTML folks, awesome Ember people, or even getting some React. Elixir, Phoenix is great too. Those are all the stacks we're most into. So yeah, this has been Web Components. If you have follow-up questions, talk to me here in the building. I'm not leaving for a few minutes. Also, you can get me at JD Steinbach on Twitter and GitHub and my blog, and all those cool places. So thank you so much for coming. And as I always like to say, if you had a good time or you learned something, bring a friend next month. But not next month, because we don't have a January meetup because of being too close to the New Year's holiday. Bring a friend in February, or 2 friends, but friends who haven't come yet. So thanks so much for being here, and have a great night.